Hello all. In this video, we learn about Introduction to Embedded System Design MSP430 Digital I/O. So, it is the digital microcontroller, digital I/O. It will be having 20 pins. It has two ports, port 1 and port 2, and MSP430G2553. 28 pins are there. So two types of microcontrollers are there, one with 20 pin and another one is with 28 pins. The 28 pin microcontroller will be having three ports in it. One is port 1, port 2 and port 3. So based on the application, we can make use of the microcontroller. Each port has 8 input output pins. Any input output can be made input or output. So any of the pin can be made as either input or output and it can be individually read or written to. So even if we want to write in the IO pin, we can write. Even if we want to read in the IO pin, we can read. Individually configurable interrupts on P1 and P2. We can even configure the pins port 1 and port 2. Choice of individually configuring pull up or pull down resistors. We can also configure the pull down registers and the pull up registers. The ports are configured by several 8-bit peripheral registers. So the ports can be configured by 8-bit registers also. Port schematic. So this is circuit diagram of the port. The microcontroller is connected to the comparator. From the comparator, the connection is given. So we have the gates. OR gate is there, AND gate is there, NOT gate is there. So this is a general port schematic of the microcontroller. So port 1.0, this is a configuration of the port. Pin number, pin names are given here. Port number 1, port number 1.1 and port number 1.2. So acknowledge clock A0, CA0 and capacitive sensings are the common options which we have in the port 0, port 1 and port 2. So digital I/O registers, MSP430 communicate with the digital I/O peripherals through a set of 8-bit peripheral registers. So there are some pins like P cross DIR, P cross input, P cross output, P cross REN, P cross SEL and P cross SEL2. So these are the pins that are used to communicate with the digital I/O peripherals. So if we want the microcontroller to communicate with the other input output devices like the output display or the keyboard or to another monitor or to any display or 7-segment display means we can make use of these ports. So to get the output or to display the output or to give other connections or to display some communications. P cross DIR. P stands for port, X stands for port number. Up to 3 ports available on MSP430G2553 based on package selected. It is an 8-bit register. It is used to define whether a pin is to be used as an input or as an output. If value of a bit in P cross DIR register is 0, it is set as input. In P cross DIR, if the register is 0, then it means that we are making use of the pin as an input. If value for bit in P cross DIR register is 1, then it is meant that the data or the pin is used for displaying the output. Default value of a P cross DIR register for all the port is 0. So by default, all the ports will be set as 0 only. But whenever we give connections, then we have to change it to 1. P cross IN. This 8-bit register stores the value of the input on a port based on the value of logic low, logic high. For MSP430 MCU, the voltage value read on the input pin will be classified as logic low or logic high. The zero value of a bit in P cross input register indicates the input value of bit as low. The one value of a bit in P cross input register indicates the input value of bit as high. So the zero value, if it is there, then it means that the input value of the bit is low. If 1 is there, then automatically the input value is high. So this is P cross output. This 8-bit register sets the digital value on a port. Setting the value of a bit as 0 indicates as like P cross input. 0 means low, 1 means high. So next is P cross REN. This 8-bit register enables the pull up or pull down register. So P cross REN is used for enabling the register, pull up register and pull down register. For 0, it disables P cross REN. For 1, P cross REN would be enabled. P cross SEL and P cross SEL2. So 0, 0, 0, 1, 1, 0 and 1, 1. So input output function is selected for 0, 0 option. For 0, 1 option, primary peripheral module function is selected. For 1, 0, reserved C device specific data sheet will be functioning. For 1, 1, secondary peripheral module function will be selected. I hope you would have learned in this video. See you in the next video. Until then, it's bye from Radhika.